Hello everyone, we're going to be looking at a stoichiometry worksheet today. It says worksheet and key. I did take the key off, so just in case you're getting excited and you thought you were going to get the key right away. I am going to be making the key available to you, but I'm not going to give you that key until after I know that you have already started to do some of the work. So with that said, I am setting up a timer here real fast. And that timer is going to say 15 minutes. And I'm going to try to keep this lecture under 15 minutes. Okay, so here we go. We're going to be looking at working some stoichiometry problems. And I've got my calculator nearby. And I have my periodic table nearby, which actually I don't. That's a lie. I'm going to have to pull up a periodic table here real fast. So let's go to pttable.com. I'm going to do that. PTTA. Whoops. Don't do. PTT. No, it's ABLE. All right. Oh, well, come on. My crazy keyboard is kind of a turd. So let's try again. I'm going to let's do that. And now I have a periodic table nearby so that I can get to it. Oh, now I see why it says P table, not PT table. No wonder. It was my fault. Okay, so let's look at some of these problems, and we're going to go ahead and get going here. The first thing I want to do is show you that each of these sets of problems has a already balanced equation. So yay, it's already balanced. You don't have to worry about balancing the equation. Yay, good stuff. So on this first one, on number one, I'm going to kind of answer these three, and then I'm going to answer a few more as we go down on this front page, and then you guys are going to be responsible for most of them on the back page, okay? So it says how many moles of O2 will be formed from 1.65 moles of KClO3. So this is how many moles. So that's going to be question mark moles, okay? So that's where I'm going. And what have I been given? I've been given 1.65 moles of KClO3. So really that goes up here, right? And then this guy is going to be over here. That's going to be my question mark. Okay, so let's see what we've got here. We've got 1.65 moles of KClO3 already set up. And I need to know the mole ratio. If I've got moles on top and moles on bottom, I know I'm looking at a mole ratio. Well, what is the mole ratio? What's the relationship between oxygen? Change colors here real fast. What is the relationship between oxygen and KClO3? Well, clearly there are 3 moles of oxygen for every 2 moles of KClO3. So it's a 2 to 3 ratio. So let's see, that's going to be 3 moles of oxygen and 2 moles of KClO3. That's my mole ratio. After I'm done with that, all I have to do is solve it, okay? And if I pull up my calculator and solve it, I get 1.65 times 3, and then divide by 2, and that gives me 2.475. Can I use that many? Nope, I can only do 3. So I'm going to say 2.48 because I have to take that 7 and 5 and round it up to 8. Okay, the next one down. How many moles of KClO3? So I'm going to be how many moles of KClO3? Okay, so that's different. Are needed to take 3.50 moles of KCl. All right, so I'm going to be starting with the 3.5 moles of KCl, so there's that. And I'm again going to be using a mole ratio. What is the relationship? Let me erase all this real fast. What's the relationship between KClO3 and KCl? Well, that mole ratio is a 2 to 2. Now, some of you fancy math types, you're going to be like, oh yeah, no, that's just a 1-to-1. Okay, if you want to do that, that's fine. You can do that. I will never do that because some of us don't like to do math in our heads at all, okay? And you don't have to. So anyway, for those of you that don't like to do math in your head, there you go. I will always write 2 moles of KCl on here, and I will write 2 moles of KClO3 up here. I will never ever go ahead and like change these numbers. I just won't. I'll just leave it right there. So what would be the answer in this case? For the math types, you already know the answer. You don't even have to do a calculator on this, but it would be 3.5 times 2 divided by 2, and that's going to give me a 3.50 moles of KClO3. That's the answer. Okay? Now the next one, it says how many moles of KCl, so I'm going to underline that, how many moles of KCl will be formed from 2.73 moles of KClO3. Well, let's see, I have to start with what I've been given number-wise, right? So I'm going to put 2.73 moles of KClO3 here. And again, I'm doing a mole ratio because it's from moles to moles. So I need to know the KCl and KClO3 mole ratio. Well, there it is. It's a 2-to-2 ratio again. But this time I'm going to put 2 moles of KClO3 on the bottom and 2 moles of KCl on top. Why? Because I want them to cancel, right? Did you see that up here too? Those cancel. And up here, this one canceled. That's how we have to do that. So this again is going to be 2.73 times 2 divided by 2, and that's going to give me 2.73 moles of KCl. And that's the answer. Okay, so hopefully you were able to do those. Now I'm going to move, whoa, careful, whoa, what just happened? Wait, whoa. All right, so you just saw that. So I'm going to let you guys do this one. Okay, so you guys, hold on. You guys are in charge of this one. It's the same thing. It's going to be mole ratios again. So you can do the mole ratios on this one. So let's look at the next one down. This one says, let's see, are we still doing mole ratio? I believe we are. This one is still a mole ratio. Oh, and by the way, up here, I'm jumping around on you, I'm sorry. Balanced equation. It already gave it to you. And because the balanced equation is already there, you're going to be able to use that, and the mole ratios are easy to find. This third one down here also has a balanced equation. Thank goodness for balanced equations. If only everything was like that. It says how many moles of O2 are produced when 1.26 moles of H2O is reacted. Okay, now I know it's going to be kind of a hard thing. It's going to be a pain in the butt for you to figure out how to do this on this sheet. You'll have to use Cami, your draw function, but I would recommend that you try. Okay, you're just going to make a line, and I did a really bad job on mine. Actually, I did a really bad job on mine. I'm going to erase it and try again because I don't need one that big because I'm just using mole ratios again, aren't I? So let's see, I'm going to write it down, 1.26 moles of H2O. That's what I'm starting with. I'm going to draw a line, or try to. And I need to convert this into moles of O2. Well, what's my mole ratio for O2 and H2O? That's going to be a 2-to-1, isn't it? So I put 2 moles of H2O on the bottom, and I put 1 mole of O2 on top. Okay? Why did I put 2's on the bottom? Because moles of H2O needed to cancel. And so then I can get my answer from there. And that's going to be, all right, come on. That's going to be, the suspense is killing me. It's 1.26 divided by 2. That's going to be a 0.630. Why did I put the 0 at the end? Because 1, 2, 3 sig figs, of course. And then I put moles of O2. Okay, and that would be my total answer. I'm going to let you guys do this one and this one. Okay, I think you guys can figure that one out pretty well. So let's move on to the next thing here. And now we're getting into grams, okay? And grams make it a little bit harder. We're going to have multiple steps, aren't we? So I only have 5 minutes left. I got to talk fast. Okay, how many grams? So we're going to go with how many grams of O2 will be formed from 3.76 grams of KClO3? Well, thank goodness we still have our balanced equation up here, right? So let's see, what have we got so far? We've got grams of KClO3 written right here. We've got grams canceling. This is the molar mass, okay? Now we have to get into molar mass. I know that 1 mole of KClO3 has a mass of 122.55. How did I get that? Well, I had to add it up on PT table. Then the next one, it says 1 mole of O2, or sorry, question mark mole of O2, question mark mole of KClO3. Hey, this is mole ratio. This is our mole ratio. So what do we know? O2 has 3 and KClO3 has 2. So this is a 3 to 2 ratio. So I put a 3 up here and I put a 2 down here. And now I've got my mole ratio done. And look at this, moles of KClO3 just canceled. Thank goodness. Got rid of them. Now I'm into moles of O2, but I don't want that. I want grams of O2. Well, I need to know molar mass. I know that there are 32 grams of O2 in every 1 mole of O2. How did I get that? Well, molar mass, you get that from the periodic table, right? You just add up their masses. So now I'm ready for the math. We've done the English. Now let's do the math. And the math looks like this. Hold on here. The suspense, right? 3.76 times 3 times 32 divide by 122.55 divide by 2 equal button. Oh my, I get 1.47 grams of O2, and that would be my answer. Okay, so again, you guys can do these. And this is the same kind of thing down here. This is going from grams to grams. So I think you guys can do those. And let's move on down here to number 18. And I will, whoa. I'll do number 18 since number 18 doesn't have a line. Okay, and then that makes it a little easier for you. I'm all the way down here at number 18 and I'm working with this balanced equation right here. It says, and I'm about to be out of time. Let me see what my timer says. 2:53. Oh, let's go fast. Hurry. How many grams of H2O, so how many grams of H2O are produced when 5.38 grams of O2 are reacted? Here we go. Let's write this down. 5.38 grams of O2. I put that in there first. I'm going to draw my line. And let's see. I need to get out of grams and into moles. That means molar mass. I know that 32 grams of O2 is the same. Whoa, what just happened? Go back. 32 grams of O2 is the same as 1 mole of O2. All right, it got small on us, didn't it? Okay, try that again. Okay, so that got rid of grams of O2. Yay. The next thing. Oh, I'm getting close. Running out of time. I know that the mole ratio is, let's see, we've got 13 grams of O2 here, and I've got, what am I going to? I'm going to H2O. That's a 10, so that's going to be a 13 moles of O2 is the same as 10 moles of H2O. Okay, I got that done. All right, keep going. I'm out of time. 1 minute, 35 seconds. Okay, so then the next thing I'm going to do is I got rid of moles of O2. I need to get into grams of H2O. Well, I know that 1 mole of H2O has a mass of 18 grams for H2O. Okay? So moles just canceled, and I'm left with 18 grams. Okay, cool. Now all I have to do is the math. Now that we've done the English, let's do the math. And the math is 5.38 times 10 times 18 divide by 32 divide by 13 equal button, and I get 2.27, so that'd be 2.33. I have to round. grams of H2O. Did I do it? Did I do it? Yes, I did. Got it done. Okay, so you have seen several examples. I've given you lots of them as we've gone through here. So hopefully you can now do the rest. And I had 27 seconds to spare. Pretty good deal.